In this video, we're going to look at how to model an addition problem on a number line. And the first step we have to take care of is rewriting our fractions so that they have the same denominator. And since my fractions have a 5 and a 2, I'm going to go with 10. So 4/5 will become 8/10 because I multiply both the numerator and the denominator by 2. And then -1/2 will become -5/10 because I multiply both the numerator and the denominator by 5. The common denominator is really important here because it determines how I set up my number line. Because I'm dealing with fractions, I don't want to just use whole numbers on my number line. I want to be more precise than that. So whatever I break my fractions into, in this case it's tenths, my number line is going to mimic that. So I'm going to start with 0 in the middle here. And I'm going to count up to 1, but counting in tenths. So I know that 10/10 makes a whole. So here's 1/10, 2/10, 3/10, 4/10, 5/10, or a half, 6, 7, 8, 9, and then my 10th line is a whole. And I'm going to do the same thing going in the negative direction. So we have -1/10, -2/10, -3/10, -4/10, -5/10, or a -1/2, 6, 7, 8, 9, and again 10/10 makes one whole, so that's -1. My number line model will start with the first number in the question, which is 8/10. So I'm going to count up to 8, and I'm going to put a dot there. And then my second number is a negative value, which tells me I'm going to travel to the left on the number line, and it's a -5, so I'm jumping 5 times. So 1, 2, 3, 4, 5. I'll draw my arrow. The value of this line is the answer to my question, which means that 8/10 plus -5/10 is equal to 3/10. And so I'm all set. We're going to look at another example. This time we're dealing with -1/4 plus -1/6. And again, my first step is to choose a common denominator. And this time I'm going to work with twelfths. So -1/4 is equivalent to -3/12. And then -1/6 is equivalent to -2/12. When I go to set up my number line, looking at the numbers I'm working with, I know that I'm only going to be working on the negative numbers. So I'm going to put 0 over to the right here, and I'm going to be counting down to -1. I'm sorry, I just realized I wrote a 10 there. Let's make that a 12. So just like before, if my denominator is 12, then I'm going to break my number line into twelfths, and 12/12 will count up to a whole. So I'm going to do 1/12, 2/12, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12/12 makes a whole. We'll count that as -1. Now I'm going to go to the first number in my problem, -3/12. I find that on my number line, so 1, 2, -3 would be right here. I drop a point. And then -2/12, I know that it's negative. I move to the left. The numerator tells me how many times to move. So that becomes -5/12. So the answer to the problem is -5/12. For this next one, I'm going to ask you to actually pause the video at this time and give it a try on your own. And then when you are all done, go ahead and press play and you can see if your work was correct. Okay, so the first step you should have taken was to find a common denominator, and our common denominator is 27. So this would be negative 18 over 27. And this would be 15 over 27. Because my denominator is 27, that means that I have to break my number line into 27ths. So I'm taking a look at my numbers, and I'm kind of guesstimating. I know I have to go down to negative 18 27ths, and I'm only traveling up 15 27ths, so I only have to deal with the negative numbers. So to give myself as much room as possible, I'm going to put 0 to the right here. And I'm going to count off, and 27 27ths will make a whole. I counted all the way down, 27 27ths got me my whole. And then I plotted a point at the first number, which was negative 18 27ths. And now I'm adding 15, so I know I'm going to the right. I'm going to just do one big loop. 15 up will land me on negative 3 27ths, which is right there. So this is equal to negative 3 27ths. And then I know that 3 and 27 can both be divided by 3. So this will simplify to negative 1/9. And that is all it takes to model addition on a number